continue breaking apart these absolute value functions to their positive version and their negative version, and we're going to focus on writing these as proper piecewise functions with the proper notation. So to write this as a piecewise function, we need to first of all determine its positive domain. Okay, where it's equal to 0, it's going to be equal to 0 at x equals positive 5 over 2. And on the right hand side of that, we know that it's going to be positive. And our positive version is going to be 2x minus 5. We don't change anything. For the negative version, the domain is going to be x is less than our boundary point, our 0 point of the inside, and it's going to be the opposite. So negative 2x plus 5. So when we draw this in, I'll draw this in here. So negative is going to be from 2 over 5, so right about there, is going to be a slope of 2. And it's going to be like this. Okay, so I've drawn a few coordinates in there. And from the negative side of this, it's going to go through the y-intercept of 5, and it's going to be like that. Okay, and I can draw, if I'm not sure, I can just draw in a few coordinates and I can draw that graph in. So there is my absolute value graph. So the domain of each piece, okay, so I've listed the domain of each piece here, and I'm just going to move that over here. The domain of each piece, and we get this domain from the 0 boundary. So where the inside is equal to 0, we establish the boundary of the domain. So we find where the inside, or inside the absolute value, is equal to 0. To get the boundary. Okay, so that gives us the vertex or the boundary point where the domain is going to switch. So we need to then describe this as a piecewise function. Oh, I've got this backwards here, but where x is less than or equal to 5 over 2. Maybe I'll just make this consistent here. Do it like that. Where it's less than or equal to 5 over 2, the equation is equal to negative 2x plus 5. So it's a linear equation with slope of 2 and a y-intercept of 5. And when it hits the boundary point, it's going to switch to positive 2x minus 5. So that green graph, if I were to continue this graph, it should go through that negative 5 y-intercept. So this is how we're going to start writing these functions. We're going to write these functions formally as piecewise functions in this way. We could also use our notation for interval notation. So instead of using this notation here, I'm just going to use interval notation. Interval notation looks like this. We use brackets like this. And it's all the way to 5 over 2 inclusive. That means equal to 5 over 2 from negative infinity to 5 over 2 including 5 over 2. And here we're going to start at 5 over 2. And in this case, we're not going to include that as our boundary all the way to infinity. And we're going to use a curved brackets because we can't be equal to infinity. We can't be equal to 5 over 2 here. And the equal to is arbitrary. Doesn't really matter where we put that.